The reaction quotient and the equilibrium constant are calculated in the exact same way. Both of them refer to the same reaction. The only difference is that K is calculated at equilibrium. Q can be calculated at any time, but the whole point of Q is just to see where it is in relation to K. So three things can basically happen. Q can be equal to K. That means this reaction is already at equilibrium, so we don't need to worry about it anymore. Q can be greater than K. If Q is greater than K and they're both talking about the same reaction, that means that this top number is larger than the top number here. So in order for this reaction to get to equilibrium, this number needs to get smaller, or this number needs to get larger, or both. That means that the reaction is going to favor the reverse reaction. If I think of it as A plus B is equal to C plus D, or gives C plus D. So for Q to become smaller, there need to be fewer products and more reactants. So we'll favor the reaction going from C plus D to A plus B. Favors reactants. And then of course, if Q is smaller than K, then the opposite is true. This number Q is smaller than the number K. In order for Q to get larger, to get to equilibrium, that means there need to be more products and fewer reactants. So it will favor the forward reaction. A plus B gives C plus D. So what Q helps do is to give the direction of the reaction. This reaction is always going to be trying to get to its equilibrium value. So when we calculate Q and it's not equal to K, if Q is larger than K, then it's favoring the reaction in the direction of the reactants. If Q is smaller than K, then it's favoring the reaction in favor of the products.